Hi everyone. If you were watching last time in the March mailbag, you'll see I got these nice little miniature breadboards, so I thought we'd actually try them out this time and use one of these in the video. So I wasn't sure which one to use, but I thought we'd probably go with something that contrasts well against the green background I've got here. So we'll push all of these other ones to one side. And we're going to be measuring voltage using the Arduino Uno, as always. Now what I've got here is a 10k potentiometer and a 10k fixed resistor. So I'm going to pop this in here. I think that's in. And then I'm going to take the resistor out the other side of it, just over to this side of the board. Now with these little miniature boards you don't get the common rails for like your supply voltage and your ground. So in our case here, our ground is just going to be this row here. And I'm going to bring in my 5 volts from the Arduino here. We're going to use that to actually create some voltage to measure. I'm going to take that into the potentiometer, and then I'm just going to take the ground back from here to ground on the Arduino. So what we've got here is actually just a voltage divider. We've essentially got two 10k resistors in series, so we should find we get sort of roughly half of the 5 volts on the center connection. And then what I'm going to do is measure off that center connection. It's a little awkward with the little breadboard here, but I'm going to use this pin here because this row here is our center connection. And I'm going to take that to analog 5, which we'll be using to do the measuring. So let's dive into some code. Right, so I've got a brand new sketch here. So the first thing we're going to need is a pin. So I'm just going to say here int sensor pin equals A5. We use pin A5. And then in the setup, I'm going to do a serial.begin 9600 for the board. And we're going to be using the serial monitor to look at the values that we're reading in. So in the main loop, now I'm going to use a float. Now I'm going to just show you all the mistakes that I made. I'm going to show you what my thinking was, the way I approached it, and you're going to see all my mistakes. So I'm going to say float sensor value equals analog read and then our sensor pin. I'm thinking that we're reading in an analog value, so that must be a float, mustn't it? Well, we'll see in a minute. Serial.print. Going to print out the word voltage, because my mindset is that I'm reading in a voltage. And then we'll do serial.println. And we'll actually print out our sensor value. So let's upload that, see what we get. Well, we get an error. So this is my first error. These should be a capital S. So let's fix that. Have another go. Uploading, that's a good sign. Just take a look at the serial monitor, and what's this? What are these numbers? These can't possibly be right. What have I done wrong here? Well, there is a little clue. The end bit here is 1023, which is a value we're expecting. So there's probably something wrong with the string at the beginning, and there is. You need to use double quotes when you're printing strings. Let's try again. Just rearrange these windows a bit. So that looks a bit better. We've got the word voltage now, and we've got 1023, which is clearly not our voltage. And that's because this is our 10-bit value that we're reading from the ADC. So actually that's an integer, not a float, because that's a number between 0 and 1023. So we'll just change that to int. We'll see it has changed to an integer on our serial output. So to get the actual voltage, we're going to have to do a little bit of maths. So we'll have here voltage equals sensor value. Now we need to divide it by 1023, and we'll talk about that number a little bit in a minute. And then we need to multiply it by 5, which is our maximum voltage. And that's a voltage, so I'm going to make that a float. In fact, I have to define that as a float. So let's see what that does. Nothing. And that's because I'm still printing out the sensor value. So let's change that to voltage. And now we're getting somewhere. This looks a little bit more like it now. Voltage, 5 volts. That sounds about right. We had 1023, so that's our maximum value. So that would equate to 5 volts. That seems right, doesn't it? We'll find out in a bit. So let's talk a little bit about this 1023. Why did I divide it by 1023? Well, I've looked at a lot of examples of people doing this, and there seems to be a difference of opinion here whether we should be dividing by 1023 or 1024, because our 10-bit ADC gives us 1024 different values, but those values are actually between 0 and 1023. So should we use 1023 or should we use 1024? Well, let's actually dive into the maths, because I couldn't really find a definitive answer on this. I'm going to have to make up my own mind on this, and I like to just prove it to myself by taking a look at the maths. Okay, so if we look at our sensor value here, we've got a maximum sensor value of 1023, and if we divide that by 1024, we actually get this quotient here of 0.999 and a little bit. If we multiply that by our maximum value of 5, it actually gives us 4.995 and a little bit. Now in contrast, if we take our maximum sensor value of 1023 and we divide it by 1023, we actually get a quotient of exactly 1. And then if we multiply that by our maximum value of 5, we get exactly 5 volts. So I'm already starting to be convinced that 1023 is the correct way of doing this. 1023 is the maximum value we can have, and that represents our maximum voltage, which is 5, so that seems correct. Let's look at the opposite end of the scale. What if we had 0? Well, if we divide that by 1024, we get 0, because of course we can divide 0 by absolutely anything. We're always going to get 0. And if we multiply 0 by 5, again, we can multiply 0 by anything we want. The result will always be 0. So in fact, on the 0, it makes no difference whether you're dividing by 1024 or 1023. You're always going to get 0. You can see we divide by absolutely anything. We're always going to get 0. So what about 1? Change the values to 1, we'll see, well, actually there's very little difference. They both give you 0.00488, and then there is a slight difference there, a slight error, but it's very small. So down at the bottom end of the scale, it doesn't make much difference. At 0, it makes no difference at all. At 1, it makes a tiny bit of difference. But of course, the error is going to accumulate as we go up the scale. So what about halfway? What about 511? We can't actually get halfway. Halfway would be 511 and a half. So let's try 511. You can see if we divide by 1024, we actually get 2.95. What about 512? Well, hang on a minute. If we divide by 1024, we do get exactly half. We get exactly half of our 5 volts, which is 2.5. So maybe 1024 is correct. But wait a minute. 512 is not exactly halfway. It's actually just over halfway, because we said halfway was 511.5. So it should be just over 2.5 volts. And if you look at the 1023, it is just over 2.5 volts. So again, I think 1023 is the correct number. Let's see what happens if theoretically we could have 511.5. You'll see again, dividing by 1023 wins, because it gives us the exact halfway of 2.5 volts. So I think I've convinced myself that 1023 is the correct divisor to use. So let's get back into the code. So let's see what happens if I just adjust the potentiometer a little bit. Hang on a minute. I'm getting 0 volts now. I either get 5 or 0. I never get anything in between the two. So clearly something is still not right here. And it isn't. It's this integer division tripping us up. This is an integer and this is an integer, so we're always going to get an integer. We're either going to get 0 or 1, and then we multiply that by 5 and we get 0 or 5. So this needs to be a float. So let's just change that and re-upload that. Let's just try adjusting that potentiometer again. Yes, finally. Finally we've got something that looks to be working correctly. We can adjust that between 5 and 2.44 volts. So that's good, right? Maybe not quite yet. Well, let's measure the voltages and see what we actually get on a multimeter. So our so-called 5 volts is actually 4.94 volts. Yeah, 4.94. And if we turn the potentiometer all the way down, all the way up, whatever way you're looking at it, we measure the voltage again, find it's actually 2.41. So we're ranging between 2.41 and 4.94. So if we go back to our code and change our maximum voltage of 5 volts and change that to 4.94 volts and re-upload that, we see we actually get a reading of 4.94, because that's actually our maximum. And if we turn the potentiometer down, you can see it actually goes down to 2.42 and 2.41/2.42. So that looks roughly about right now. I think we've got reasonably accurate voltages, or as accurate as my multimeter is. So I think we can now confidently say that we know how to measure voltage. Okay, so we'll wrap that up here. We've successfully got the voltage measurements correct now after a bit of messing around. What we can do in the next video, we can actually take a look at that TMP36 temperature sensor. We can actually use this same technique to measure the voltages that we're getting off of that. So thanks for watching. If you haven't done so, please subscribe to the channel. We're getting close to 1,000 subscribers now. I think we've just passed 900, so we're working towards 1,000 subscribers. So please support the channel by subscribing if you haven't already done so. I'll see you next time.